According to neuropsychologist Christopher self-monitoring theory, deficits in internal self-monitoring mechanisms that compare the expected with the actual sensations that arise from a patient's intentions can lead to misclassification of internal events, such as internal speech processes, as external events. There are many forms of hallucinations. Hallucinations can range from visual to auditory. If these hallucinations are controlled, they can be enlightening or fun. On the other hand, if hallucinations aren't controlled, they can create psychosis or terror. Here's an example of a visual hallucination that would be easily recognized as fake, so would generally not be a terrifying experience. Then, there are the uncontrolled visual hallucinations. This is an example of someone who experiences a hallucination that the floor beneath them is now a river. Because the hallucination is uncontrolled, the experience can be unsettling. Auditory hallucinations can be just as malicious as visual ones. Here's what a schizophrenic patient may hear.
No, you can't. Stupid. The boys in the cars. Jump now. Jump in front of the car. Go on. Do it.
Now that we're more familiar with the different forms in which hallucinations can occur, let's explore what hallucinations are. A hallucination is a perception in the absence of a stimulus. These perceptions, that occur in a conscious and awake state, have the qualities of real perception in that they are vivid and substantial. Hallucinations are different than other related phenomena, such as dreaming, which does not involve wakefulness, or illusions, which involve distorted or misinterpreted real perception. Hallucinations can occur in any sensory modality, such as visual, auditory, olfactory, or tactile, to name a few. A person can experience hallucinations for a number of reasons. Drug use, such as marijuana, LSD, cocaine, and even alcohol, can all induce hallucinations. They can also occur because of delirium or dementia, epilepsy that involves the temporal lobe, fever, especially in children and the elderly, narcolepsy, psychiatric disorders such as schizophrenia and psychotic depression, sensory problems such as blindness or deafness, and finally severe illness such as liver failure or brain cancer. So what actually happens in the brain during a hallucination? According to Dominic Vitek, there's a striking correspondence between hallucinatory experiences and particular portions of the ventral visual pathway in the visual cortex which are activated. New knowledge comes especially from the ability to image the brain and to monitor its electrical and metabolic activities while people are hallucinating. Such techniques, coupled with implanted electrode studies, which allow for around-the-clock monitoring, have been used to define which parts of the brain are responsible for different sorts of hallucinations. Hallucinations of faces, of color, of texture, and of objects, for example, each activated particular areas known to be involved in specific visual functions. Colored hallucinations result in the activation of areas in the visual cortex associated with color construction. Facial hallucinations of cartoon-like characters result in the activation of the fusiform gyrus. Visions of deformed or dismembered faces resulted in heightened activity in the superior temporal sulcus, an area specialized for the representation of the different parts of the face. Further, text hallucinations activated the visual word form area, a highly specialized area found in the left hemisphere. Vitek also observed a clear distinction between normal visual imagination and actual hallucination. For example, imagining a colored object did not activate the V4 area, while a colored hallucination did. Such findings confirm that, not only subjectively but also physiologically as well, hallucinations are unlike imagination and much more like perceptions. Finally, the study showed that the brain is unable to tell apart vision from reality. Now that we know what hallucinations are and why they occur, let's explore the Charles Bonnet syndrome. This is a picture of Charles Bonnet. In 1760, he was the first scientist to describe the syndrome that is now named after him. Charles Bonnet syndrome is a condition that causes patients with visual loss to have complex visual hallucinations. Oliver Sacks, a British neurologist, studied patients with Charles Bonnet syndrome. Here's the first-hand account of one of his encounters with a patient that had CBS.
I went in to see her. It was evident straight away that she was perfectly sane and lucid and of good intelligence, but she'd been very startled and very bewildered because she'd been seeing things. And she told me, the nurses hadn't mentioned this, that she was blind, that she had been completely blind from macular degeneration for 5 years, but now, for the last few days, she'd been seeing things. So I said, what sort of things? And she said, people in Eastern dress, in drapes, walking up and down stairs. A man who turns towards me and smiles, but he has huge teeth on one side of his mouth. Animals, too. I see a white building, it's snowing, a soft snow. I see this horse with a harness dragging the snow away. So I said, is this like a dream? And she said, no, it's not like a dream, it's like a movie.
There's clearly a wide array of visual disturbances which can occur when vision is lost or compromised. But essentially similar array of disturbances can also occur when the damage lies not in the eye itself, but higher up in the visual system, especially the cortical areas involved in visual perception, including the occipital lobes and their projections into the temporal and parietal lobes of the brain. The study of Charles Bonnet syndrome sheds light on how the brain compensates for losses in vision and hearing. In CBS, when retinal cells no longer receive and relay visual images to the brain, results of eye disease or damage to the optic pathways, for example, the visual system begins creating its own phantom images. Ophthalmologist Jonathan Throbe explains that the brain is a mashup of stored visual memories. When visual cells in the brain stop getting new information, the cells compensate by creating their own false images. The misfirings that occur in the brain, a result of the interpretation of visual imagery in the absence of corresponding visual input, is similar to the neurological mix-up that occurs in patients with phantom limb syndrome, which refers to the brain continuing to process pain signals from a limb that's no longer there. Because of the similarities between the phantom limb syndrome and CBS, Charles Bonnet syndrome can also be referred to as phantom vision syndrome. As I previously mentioned, experiencing controlled hallucinations can be enlightening or fun. Drug use allows people to change the way in which their mind functions for a short time. Induced hallucinations, perceptual distortions, or altered states of awareness offer a different and unique view of reality, an experience that has the ability to be therapeutic. For this reason, psychedelic substances have long been used for healing, ceremonial, or mind-altering subjective experiences. Taking LSD and watching the world around you transform into a kaleidoscope of colors and motions that weren't previously there can have a profound impact on the way in which an individual perceives reality. For example, in his book, Oliver Sacks writes about the life-changing experience he had after he took LSD. The way in which the drug altered his state of mind made him realize that smoking was doing tremendous harm to his body. Regarding the experience, he writes, "My eyes became a microscope, and I was able to see inside each skin cell. And I saw that I was choking myself from the inside by smoking 5 packs of cigarettes a day, and the debris was clogging my cells. At that second, I quit smoking." How is such an experience possible? Scientists with the Mount Sinai School of Medicine and Columbia University in New York have worked towards explaining what causes the mind-bending effects of hallucinogens. Hallucinogens act on brain molecules called 5-HT2A receptors, which sit on the surfaces of brain cells and interact with signaling chemicals that naturally flow through the brain. Interestingly enough, psychedelics interact with the same receptors as serotonin. However, the researchers found that LSD produced an array of electrical and cell signaling responses in the cortex that were very different from those induced by non-hallucinogenic compounds. When LSD activated the receptor, it not only triggered the expected changes in the cell, but it also affected a special layer of cells in the cortex called layer 5. This layer of cells is the output layer of the cortex. Its function is to gather up decisions made in the cortex and relay them to other brain regions. The researchers also hypothesized that the layer plays a role in filtering information so that other brain areas don't get overwhelmed. Thus, the effects of hallucinogens may be in that psychedelics disrupt this filtering, which causes the brain to experience a sensory overload, or in other words, a less filtered experience of sensory inputs. This study shows that, similar to the brain misfiring in Charles Bonnet syndrome, drug use can cause similar effects in that the brain cells become overactive and begin creating false images, also known as hallucinations. So what can studying hallucinations teach us about the brain, as well as the impact that brain functions have on reality? Neuroscientist Vilayunar Ramachandran states that the occurrence of a hallucination often points to the brain structures and mechanisms involved, and can therefore provide more direct insight into the workings of the brain. By studying hallucinations, scientists can better understand why, even though our picture of the world seems coherent and unified, it actually emerges from the activities of 30 or more different visual areas in the cortex. Another conclusion is that reality is not absolute. Cognitive aberrations like hallucinations demonstrate how little we can count on a single, unquestionable version of reality. It's as if each of us is hallucinating all the time, And what we call objective perception involves merely selecting the one hallucination that matches the current input.